Okay, so let's go ahead and start our new section on solving quadratic equations. Okay, just a very fancy word. Pretty much all it means is that your equations will now involve a variable that has an exponent of 2. Okay, so far, whenever we've talked about solving equations, we've only worked with linear equations where we did not have an exponent. Okay, but now we're going to look at different ways that we can solve a quadratic equation. Okay, so we're going to start off with a method called factoring. We actually took about a week and a half to cover all different ways to factor. Now let's look at one of the types of problems where factoring can come in handy for us. Okay, so we're going to start with solving quadratics by factoring. Um, they do kind of take a little bit of time in the notes to talk about factoring and comparing them to graphing. Now, we haven't started graphing yet, though. So, this little tidbit right here, we'll just leave that alone and, look at some of those that terminology whenever we get to the graphing section. Okay, so the first thing is that we want to set our quadratic equation to 0. Now, the one that they had given us, since they'd already talked about graphing, they introduced having both the y and the x in the equation. Since we haven't talked about graphing yet, the only thing that I want you to worry about doing is what we say setting our equation equal to 0. So we just want to make y be 0. Okay. And that will make a little bit more sense when we get to the graphing because you can see the pictures and why do we do that. Okay. So you always want to make sure that your equation is set equal to 0. So I'm going to write it off to the side a bit. X squared plus 3x minus 10 equals 0. Okay. So, and then step 2, we need to factor the left-hand side, okay? So if you look at the left-hand side, we have x squared plus 3x minus 10. All right, so we have lots of different methods of factoring. I will give you kind of a clue. Most of the time, we're going to be using the trinomials, okay? Because with quadratics, you could have a binomial, but most of the time, what's going to happen is you're going to have a trinomial. And so, since my leading coefficient of this trinomial is 1, I get to use the shortcut method. Okay. Now, this is still going to be set equal to 0. Nothing's going to change with that. I'm just kind of rewriting the left-hand side in a different way, okay, in hopes that it's going to help me solve this equation. So, I write an x on both sides in both factors. And I asked myself, I need two numbers that multiply together to give me negative 10, add together to give me a positive 3. That's going to be a positive 5 and a negative 2. All right. So how is this going to help me solve the equation? Okay. How am I going to be able to solve this better than if it was written in a simplified form? Why is the factor form going to help me? Well, I'm going to use an algebraic property that kind of seems simple, almost like it's common sense. But off to the side, let's think about this. If I have two things that are multiplied together to equal 0, so let's just say something times something equals 0. All right, that's kind of what we have over here. Something times something equals 0. So what do those somethings have to be? Well, think of some numbers. Okay, let's see. 2 times 0 equals 0, right? Or 0 times 7 equals 0, right? Um, 6 times 0 equals 0, okay? I'm just thinking about any two numbers that multiply together to give you 0. Or 0 times 0 equals 0, right? What's in common on this on with all of these factors? Okay, what's the thing that's in common? Well, we see that with a factor, when you have two factors that multiply together to get 0, the equation is true if and only if one of your factors, at least one of your factors, has to be 0. Okay, in this last case, they both were 0. Okay, so when you have a multiplication problem set equal to 0, you can for sure say, well, either the first factor is 0 or the second factor is 0. If either one of those things happen, my equation will be true. So let's look at our quadratic and write that mathematically. Either the first has to be 0 or the second's going to have to be 0, okay? Or they both could be 0. So what we do is we take this equation and we write two new, entirely new different equations, okay? And we're using the multiplication of the 0 property of multiplication. And so I say, well, I am going to have either x plus 5, that's one of my factors, either that has to be 0, or, we won't get into that. Maybe we'll talk about that later. And x minus 2 could be 0 as well, okay? And now, so to solve my quadratic equation, okay, the answers to these two very simple linear equations will satisfy the quadratic equation. So that was step 3, set each factor equal to 0 and solve for x. So what do I need to do to solve for x? I'm going to subtract 5 from both sides. X equals -5. And then add 2 to both sides. X equals a +2. Okay, so these are my two answers. Step 4 talks about writing your answers using a curly bracket. In mathematics, when we want to communicate answers to each other, there's different types of notation. One of those is called set notation, and the way set notation is just, like I said, it's a notation, so it's a form of writing, a form of communicating. It just has you, if you have multiple answers, what we do, x equals, what we do is we put them in little tiny curly brackets, okay? And we separate them with commas. Okay, so these curly brackets indicate to us that it can either be -5 or 2, either one. Okay, so it's just a form of communication. You don't have to do this in there, okay? That won't be necessary. Okay, let's move on and do a few examples, okay? So these are gonna be fairly simple right off the bat because we just left our whole section on factoring. So if you were okay with factoring, you're gonna be perfectly fine with these. Okay, so first step, make sure it's set equal to 0. Already done, okay? Second step, factor the left-hand side. Like I said, most of these are going to be trinomials, so you're going to see that they're going to factor into two binomials, okay? Since my leading coefficient is 1, I get to use the shortcut method where I put an x on both sides, x. I need two numbers that multiply together to give me 3, add to give me 4. That's going to be a +4 and a +1. Okay, so I factored the left-hand side. Now, this is the part where you can use that multiplication 0 property, okay? Where I know if I have a multiplication problem with two things multiplied to equal 0, that this equation will be true if either one equals 0, okay? I know that that has to be true, okay? And really, you don't need the parentheses anymore, okay? Because we no longer have that original equation where it was a multiplication problem. What we did was we created our new equations, which whenever we created those equations, guys, they happen to be linear equations. And you already have linear equations in the bag. You know what to do, right? If you have x plus 4 equals 0, well, just subtract 4 from both sides, okay? And you're left with x equals -4. All right, if you have x plus 1 equals 0, what do you got to do? You got to subtract 1 from both sides, okay? We're just solving some linear equations. X equals -1. So those are my two answers. And like I said, I'm going to skip writing them in with the notation of set notation. Okay, I'm going to leave number 2 for you guys. Number 3, all right, it's set equal to 0. Perfect. That step's already done. Now what we need to do is factor. Since I have a trinomial with a leading coefficient of 1, right? I get to use the shortcut method, okay? They're going to factor nicely into two binomials, okay? It's still set equal to 0. Don't forget about that. Now we're working with equations. Last time we just had expressions, right? Where we were practicing factoring those expressions. Well, now we're actually putting this factoring into use by solving quadratic equations. So two binomials, since the leading coefficient is 1, I get to use the shortcut method. I need two numbers that multiply together to give me -2 and add together to give me, that's a +1, right? Okay, two numbers that multiply together give me -2 and add together to give me +1. I believe that's a +2 and a -1. Okay, if you need a little help with it, write your list off to the side with all the pairs that satisfy that -2 multiplying to -2, and then see which one adds to +1. Okay, left-hand side is factored. Now it's time to set each piece equal to 0. So I'm creating two brand new equations. So maybe I'll even draw them in a different color since these are brand new. This is a new equation. X plus 2 could be 0, and x minus 1 could also be 0. Okay, now subtract 2 from both sides. You have x equals -2. You subtract 1 from both sides, or add 1 from both sides on here, you have x equals a +1. So my answers, x equals 1 or x equals -2. So we're going to find out with quadratics when we get to graphing them. Actually, I'll kind of show you what a quadratic will look like, just so we can start getting ideas. Um, this quadratic might look like something like this. Okay. So it's kind of like a U shape. It also could be upside down, like the arch looking. Um, and so whenever we are solving a quadratic, all right, we're going to remember when they said set the quadratic equal to 0. Well, when we're looking at the x values and we set those values equal to 0, okay, we set that y value equal to 0, that's going to be wherever it falls on the or this x-axis, okay? So when we're finding solutions, we're finding out where does it cross the x-axis, okay? And you can see that it crosses twice. It crosses here and it crosses here. Okay, what are these points? I didn't really make any numbers on here. This is just a very rough sketch. But right here, x equals 1. Okay, this is x equals -2. So like I said, I'm just drawing a rough sketch, but this is an idea of what it would look like. And the reason we have two solutions is because we're trying to ask ourselves, where does it cross the x-axis? And we'll find out lots of different things. Most of the time, it's going to cross twice. Okay. Now, there could be some quadratics that look like this, where it just goes boop and it touches once. There could be some quadratics that look like this and it never touches that x-axis. Okay. So we'll see different scenarios where that's going to happen. Where there might be one solution or there might be no solutions. But for a quadratic, most of the time you're going to see that there's going to be two solutions. Okay, so let's go for number 4. So I need two numbers, or I'm sorry, I got a quadratic. I got it set equal to 0 already. So the next step will be to factor, and since it's a trinomial with a leading coefficient of 1, I know my left-hand side is going to factor easily using that shortcut method. I need two numbers that multiply together to give me -27 and add together to give me +6. I believe that's a +9 and a -3. Now that the left side is factored, you get to set each factor equal to 0, okay? I'm creating two brand new equations, okay, by analyzing this factored form and saying, hey, if I have a multiplication problem and the answer is 0, I know that this equation will be true if either factor is 0, okay? So that's where I create these two brand new linear equations, okay? And they're very easy to solve for the most part, okay? We're just going to be adding or subtracting that constant away. once our um, once our quadratics get a little more complicated, we might have a little bit harder linear equations to solve, but not really. They'll always be pretty simple for you. Okay, I'm going to leave number 5 for you guys to do. Let's do number 6. So I have a quadratic equation. It's already set equal to 0. Okay, so keep that in mind. Sometimes we're going to find out you got to solve it. And then so since it's a trinomial, I know it's going to be factored into 2 binomials. And since the leading coefficient is 1, I got to do the shortcut method where I just got to stick those x's there. All right, I need 2 numbers that multiply together to give me negative 20 and add together to give me negative 1, okay? Don't forget, if you don't see a coefficient, it means that there's a coefficient of 1. And since there's a minus sign, it's a negative 1. I think that's going to be a negative 5 and a positive 4. I think those will satisfy my equation. Okay, so since I have a multiplication problem where the answer is 0, I know that this multiplication problem will be true if either one of these equations are true, these linear equations. I think it's really interesting that, you know, when we're learning how to solve a quadratic equation, our goal here is to somehow create 2 linear equations that we already know how to solve. So what we're really doing is manipulating our quadratic equation where we can analyze it and pull some information out by using that multiplication 0 property and create these linear equations that we already know how to solve. So x minus 5 equals 0, so that means x equals a positive 5, right? Add 5 to both sides. X equals a negative 4, okay? So those are my 2 answers. Okay, so I'm going to leave number 7 for you guys. Here on 8, my quadratic equation is already set equal to 0. So since it's a trinomial, I know I'll have 2 binomials. Okay, I know I'll have 2 binomials. And since the leading coefficient is 1, I get to use the shortcut method. I need two numbers that multiply together to give me positive 16, add together to give me negative 8. I believe that's going to be negative 4 and negative 4. Okay, so set each piece equal to 0. Oops, x minus 4 equals 0. Now you see that my factors ended up being the same. So on both factors, we're going to get x equals 4. Now we're creating a list of possible answers, okay? And so x equals 4 is the only answer. So really, you don't have it twice, you just have it once. So the answer is x equals 4. So it doesn't really matter which one you use. What would that look like on the graph? Okay, that would look like that one scenario where the quadratic, so let's just say 1, 2, 3, 4, just touches down, okay, and it doesn't cross, okay, because if it would cross, it would have to cross twice. This is just kind of bounces off of that x-axis, okay, and that's where that solution's coming from. Now, like I said, we're going to spend a day or two on graphing these, but not very much time. So I'm going to kind of show you these rough sketch drawings every once in a while, just so that you start getting familiar with it. Okay, so let's move on. One of the things that makes quadratics more difficult to solve, okay, than a linear equation is the fact that there are 2 different terms that involve x's. So it's hard for me to isolate the x because 2 different terms that are unlike terms because they don't have the same exponents involve an x. So I can't combine them. So I have to find a way to kind of manipulate them like that. And so factoring is a great method to kind of pull those x's out of the terms, okay, where you're creating just 2 factors that involve x as opposed to 2 terms that involve x. So here I have I really just have a binomial here, right? So I'm not going to factor into two binomials. What do I need to look for when I factor? Make sure you're always looking for that greatest common factor. Can you divide anything out of both of those pieces? Yeah, you can divide an x out of both of them, right? So we divide out an x squared divided by x is x minus 8x divided by x is 8. Okay, so these are my two factors, x, okay, times x minus 8. So my factor is x equals 0 and x minus 8 equals 0. Okay, this first guy over here, x equals 0, it's already solved. Okay, could not be any more easier. You don't have to do anything now. We know x equals 0. Um, Here, all you have to do is add 8 to both sides. X equals 8. Okay, so all I did was factor out a common factor of x. Okay. Um, all right, number 10, it's a binomial. Let's look first and see if there's something that you can pull out evenly of both factors. Okay, so it looks like I can take a 3 out and an x. Okay, a 3x. Pull that 3x out of there. This is going to give you just x plus 5. Okay, so make sure you're doing that division. 3x squared divided by 3x is x. 15x divided by 3x is 5. So now we set each piece equal to 0. Okay, so I have 3x equals 0 and x plus 5 equals 0. So I divide each side by 3. 0 divided by 3 is just 0. Okay, and then subtract 5 from both sides and you have x equals -5. So those are my two answers, 0 and -5. Okay, I'm going to leave number 11 and 12 for you guys to do. Okay, so if we recall, we had lots of different methods to factoring. We just saw that using the greatest common factor helped us, factoring trinomials helped us. What are some other techniques? Remember there was a technique of the difference of squares. Okay, look at 13, 14, 15, and 16. Those kind of look like difference of squares, right? Because we have two terms. It's a subtraction problem. And it almost looks like I got some perfect squares going on. So here on 13, there's no greatest common factor like there was in the previous ones, but I do notice that I have two terms where the first one is written as a square. It's a subtraction, and I think 64 could also be written as a square, right? All right, so what does that mean about factoring that left-hand side? Remember, if you have a squared minus b squared, you get to factor that to saying that a minus b or a plus b and then a minus b. Doesn't really matter which one you put first, but we'll make sure we're consistent. Okay, so we have x plus 8 equals 0 and x minus 8 equals 0. So subtract 8 from both sides. We have x equals -8. And then add 8 to both sides. X equals +8. Now I am going to show you some notation that's going to help us later this week. So when I am communicating an answer with somebody and I have x minus 8 equals -8 and x equals a +8, I have a really quick way of showing you that, okay? And it looks like this. X equals a positive or negative 8, okay? It's read x equals plus or minus 8, okay? X equals positive or -8. It's like I said, math is about writing as little as possible, but compacting as much information in that writing as well. So that's what kind of makes math so confusing sometimes when you're reading it. There's very little to go off of sometimes. So this is a notation that's going to help us later whenever we use what we call the quadratic formula. Okay. Um, I'm going to leave number 14 for you guys. Let's do number 15. So there's nothing I can divide evenly into 4 and 81, but this is two terms, almost looks like perfect squares. The first term, not a perfect square yet, but if you rewrite it like this, then you can clearly see that it is in fact a perfect square, okay? And then also the second term, is it a perfect square? I don't know. Let's see. Can you write it with a square? Yep. Okay. So these factor, you take into two binomials. Okay. You take the first term plus the second term, and then the first term minus the second term. All right. All right. So now we set each piece equal to 0. All right. So for this left-hand side, I'm going to need to subtract 9 from both sides. So 2x equals -9. Sorry, I'm going off into the next one. And then divide each side by 2. Okay, x equals -9 halves. And over here, it's going to be the same, except we're going to add 9 to both sides. So we'll end up, after we divide by 2, x equals a positive 9 half. So what's a quick way I could write this? X equals a plus or minus 9 halves, okay? I want you to get used to that notation because you're going to see that. Okay, I'm also going to leave number 16 for you, and I'm going to solve the next ones in the next video.